Hi guys, in this video we're going to take a look at the basic functional groups called alcohols, phenols, ethers, and thiols. In separate videos we'll then take a look at a little bit of the special nature of each of these different ones, but let's just introduce all of these guys. So first, alcohols. Okay, so this is a compound that has an OH group attached to it. So again, the R represents some generic alkyl carbon-based substituent. This substituent is sometimes called a hydroxyl or hydroxy substituent, coming off of whatever the main alkyl chain is. A phenol. Okay, this is going to be an aromatic system, such as benzene, that also contains an attached alcohol group. So this entire ring structure with the OH group is called a phenol. And I'll just put here that you don't just have to be benzene. Sometimes these are incorporated into other parts of molecules. Third, we have what are called the ethers. And these are molecules that have two alkyl groups attached. The two alkyl groups could be the same or might be different, but there's no hydrogen attached. There's another alkyl group attached to the ether. And then lastly, okay, we have our thiol functional group, which is very similar to the alcohol group. It's just that we're going to substitute the oxygen with the sulfur. Okay, and this one is sometimes, instead of being called a hydroxyl or hydroxy substituent, it's called a sulfhydryl group. Now, one of the key things about all of these groups is that notice that, and let me put my lone pair of electrons on here, all of these groups have either oxygen or sulfur, which is a fairly electronegative atom. So these types of groups tend to be much more polar than you would see in a typical just regular alkane or alkene molecule because of the presence of these double bonds and also, the presence of these lone pairs of electrons and also the presence of these fairly electronegative atoms, either oxygen or sulfur. I will mention this particular one, the ether, it is somewhat polar, but not nearly as polar as these others. This is almost more like an alkane or an alkene in terms of its polarity. The main reason for that is that there's not an attached hydrogen. So the thiol, phenols, and alcohols, they tend to be quite polar, often fairly high boiling points and melting points, and also usually have fairly good solubility. Ethers tend to not be very soluble in water at all. All right, continuing on with our discussion of alcohols, phenols, ethers, and thiols, let's take a look at the nomenclature of these four functional groups. And we'll do this sort of all in a sequence, just so we can get this out of the way. Alcohols. Now, these are a very, very important class of molecules. And they're going to use the suffix OL. All right, so let's just take a look at a very simple molecule. Here we have a carbon chain with 3 carbons, and our alcohol is coming off of carbon 1. So from prior knowledge, we know that a 3-carbon group is going to have the prefix prop, and then we are going to tack on this OL. So this is based off propane. Okay, but what we're going to do is we're going to drop the E, we're going to cross out the E and tack on OL. So this becomes propanol. And again, we're ending that with the OL suffix. Be careful when you're having to write this out, especially if you write in cursive. Make sure this is an O, not an A. Propanal is actually a compound, but it's not an alcohol, it's an aldehyde. So make sure that your O is a nice round O when you're writing these out. So that's a real simple alcohol. Let's take a look at one that has maybe some branches on it. So here's a compound now that if we were to try and name this one, we would number it in this fashion. See, we have a 3-methyl group, and then our alcohol is coming off of the 3 position here. So this would become 3-methyl 3-pentanol. Okay, and again, this 3 is indicated here right in front of the word pentanol to indicate the position where the OH is coming off. Lastly, let's take a look at a cyclic example. So here we have a cyclohexane ring, but now it has an OH group and a methyl group. So now we have to actually look at priority. Well, alcohols, or any functional group that has an oxygen, is always going to take priority in naming and numbering over a regular alkyl substituent. So I'd want to number this carbon of the alkane chain, number 1, and then worry about the substituents. So this would be 2, 3, 4, 5, and 6. So the name of this compound would then be 2-methyl 1-cyclo, don't forget the cyclo, hexanol. Okay, and I would mention that because the alcohol is the dominant group in this particular molecule, sometimes you can omit this one, or you'll see this name omitted. So the name 2-methyl-cyclohexanol is the same thing as 2-methyl-1-cyclohexanol. This would be sort of an optional thing when it came to naming and numbering. All right, so let's, in the next part of the video, we're going to look at phenols. All right, so to name a phenol, you actually use the word phenol in the name. Pretty simple. Now, to start off, this molecule that has a benzene ring and an OH attached, with just this attached, nothing else attached to the ring, this is actually called phenol. That is the molecule called phenol. However, if we start to put other things on the benzene ring, then it changes the name a little bit, and we have to indicate what other things might be on there. So for example, if I had this compound, okay, again, as we talked about before, alcohols are going to take priority in naming and numbering, so I would number that carbon 1, 2, and 3, 4, 5, and 6. So this would now be 3-methylphenol. Likewise, if I had a different substituent, let's use a halogen. Okay, so this compound, again, I would number my OH group. It's going to take priority over any halogen groups as well. This would be 3-chlorophenol. So that covers the basics of nomenclatures of phenols. Let's take a look at the nomenclature of compounds that contain ethers. And these actually will use the word ether in the name. So if I had a very simple ether, like this one, okay, notice it's sort of symmetric, has 2 methyl groups on either side of the oxygen. This is simply called dimethyl ether. Let's do another one like that one. Now we'll use our line angle drawings. Looks kind of like a bird almost with oxygen in the middle. This molecule, again, has 2 symmetric substituents coming off it. This is called diethyl ether. Very important historical compound. This actually was the very first anesthetic used by William Morton, I think back in the mid-1800s, 1848. He was a dentist and actually demonstrated that if you administer this to a patient, they would essentially become unconscious. You could do a surgery. When they woke up from that, they wouldn't have any pain. So this is a very important historical, medically relevant ether as well. Now, what do you do if you have a non-symmetric ether? So let's say we have one that has a methyl group and an ethyl group. Well, you list the 2 substituents alphabetically and then just tack the word ether on there. So since ethyl comes before methyl, this would be ethyl, methyl, ether. All right, so that covers the basics of nomenclature for ethers. All right, so nomenclature for thiols. Again, similar to what we've seen before, the word thiol will actually be used in the name. So for a simple example like this, we have a propane chain. Okay, so we would just tack on the word thiol. So this just becomes propane thiol. Notice the nomenclature here is definitely different than alcohols. If this were an OH group, this would just be propanol. But because we have a sulfur now, we want to indicate that there is a sulfur and an oxygen. We put on this word thiol, and notice we keep the E in the propane name. Let's look at a compound like this. Okay, so here we have now a cyclic group as our parent chain. We would want to give the priority in naming and numbering to the carbon containing the SH group. So this would be 2-methyl. Okay, so 2-methyl covers that. Now we have cyclopentane thiol. Now you could optionally put a 1 in there just to indicate that the thiol is coming off the 1 position. But in a simple molecule like this, it would be assumed that the thiol actually came at the 1 position. All right, so that covers the basics of nomenclature for these really important groups, the alcohols, phenols, ethers, and thiols. In the next set of videos, we're going to actually take a look at the physical properties of these and then a little bit about the reactivity.